For decades, if you wanted to build the Linux kernel, you really only had one choice of compiler. But that's all changing. Today, we're going to dive into a pretty massive shift in the kernel world, building the most popular kernel on the planet with the Clang and LLVM toolchain.
Okay, so to get this, you gotta understand the two main players here. In one corner, we've got GCC, the GNU compiler collection. It's the veteran, right? The old champion that's been tied to Linux from the very beginning. And in the other corner, you've got the challenger, Clang, and its LLVM infrastructure, a much newer, more modular toolchain that's been making some serious waves.
The story was always super simple. The Linux kernel and the GNU toolchain, they basically grew up together. This partnership was so fundamental that for most of Linux's history, the idea of using anything else was, well, it was almost unthinkable. GCC was just the standard, the bedrock.
So what exactly is this challenger, LLVM? Well, it's not just one single compiler. It's better to think of it as a whole collection of modular tools, kind of like a big box of Legos for building compilers. And Clang, that's the most famous tool built from those blocks. It's the part that understands C and C++, which are, of course, the languages of the kernel.
Now, you might be thinking, whoa, hold on. Switching out the entire toolchain for something as massive and complex as the Linux kernel, that sounds like a complete nightmare. But honestly, you'd be surprised. The kernel developers have made this incredibly simple.
And here it is, the crucial point. There's no crazy complex configuration file. You don't have to go rewriting a bunch of build scripts. The entire power of this whole LLVM ecosystem, it's all unlocked with just one simple switch that you add to your build command.
Let's just break it down. It really is just two steps. First, obviously, you need to have a complete LLVM toolchain installed on your system. That means Clang, the LLD linker, all those other utilities. Once that's ready to go, you just add LLVM = 1 to your normal make command when you build the kernel. That's literally it.
And this example right here shows just how powerful this is. Cross-compiling for a totally different processor, like ARM64, used to be a whole thing. You'd have to set up these complex cross-compilers. With Clang, because a single compiler often supports multiple targets, you just tell it the architecture, add LLVM = 1, and you're off to the races.
So what's the magic happening behind that one little command? Well, LLVM = 1 isn't just one setting. It's really a shortcut that tells the build system to swap out the entire suite of standard GNU tools for their LLVM equivalents. We're talking the compiler, the linker, all the way down to the archiver and the symbol lister, the whole shebang. Okay, so we've covered the how, and it's surprisingly easy. But that brings us to the really exciting part, the why. So let's get into the incredible new capabilities, the superpowers that using Clang actually unlocks for kernel developers. And it's a totally fair question. If GCC works so well, why even go through the trouble of trying something new? Well, the answer is in these superpowers, these really advanced features and tools that are either completely exclusive to the LLVM ecosystem or just way more deeply integrated with it. First up is BPF. You may have heard of it. It started as the Berkeley packet filter, but it's evolved into this revolutionary tech that lets you run these safe, sandboxed mini programs right inside the kernel. It's amazing for high-performance networking and tracing. And the engine that compiles these BPF programs, it leans heavily on LLVM's special BPF backend. And hey, you don't have to take my word for it. The kernel's own documentation makes it crystal clear. Modern high-performance BPF is totally intertwined with LLVM. This just makes Clang the natural choice for anyone who's really pushing the limits of what BPF can do. All right, superpower number 2 is for hunting down some of the sneakiest, most dangerous bugs out there, the kernel memory sanitizer, or KMSAN. It's a dynamic debugging tool that finds when the kernel tries to use uninitialized memory, which can cause all sorts of chaos. And this is a feature you can only get when you build the kernel with Clang. But, and this is a really important but, KMSAN is a developer tool. It's not something you'd ever want to turn on for a production server. It adds a ton of overhead, slows things down, eats up memory. But for catching those really tricky once-in-a-million bugs during development, it is absolutely invaluable. How about making your kernel faster based on how you actually use it? Well, that's AutoFDO. It's a type of optimization where you collect performance data from a running kernel, and then you feed that data back into the compiler.
This lets it make much, much smarter decisions on how to optimize the code specifically for your workload. And yep, you guessed it. This is another feature that's specifically unlocked by the LLVM toolchain. If you want to use this powerful performance tuning tool, you have to be building with a recent version of Clang. And this last superpower is maybe the most forward-looking one of all, Rust. The whole effort to start writing parts of the kernel, especially drivers, in the memory-safe language Rust is one of the most exciting things happening in Linux right now. And that entire initiative, it's built on top of the LLVM ecosystem, which Rust uses for both compiling its code and for talking to all the existing C code in the kernel. So, you take all these powerful new capabilities, and what does it all mean for the future of kernel development? Well, it means we're moving away from a world with just one choice to something way more flexible and dynamic. And listen, this isn't just some theory or a fun experiment. Building the kernel with Clang is already happening at a massive scale. We're talking major projects like Android and Chrome OS. It powers the massive data center fleets at companies like Google and Meta. This stuff is production tested and ready for prime time. And all this brings us to the new reality for kernel developers. GCC is still the trusted, battle-hardened standard. It is not going anywhere. But Clang and LLVM now offer a parallel path, one that's just a hotbed for innovation, for new tools, for new languages like Rust, and for new ways to optimize. And at the end of the day, having two world-class competing toolchains is a huge win for the Linux kernel. This competition just pushes both projects to get better. It introduces new ideas, and it gives developers the freedom to choose the absolute best tool for what they're trying to do, which just makes the entire ecosystem stronger for all of us. And that kind of leaves us with a final thought to chew on. As the Linux kernel keeps evolving, maybe its greatest asset isn't just the millions of lines of code inside it, but the growing diversity and power of the tools we can choose from to build its future. Thanks for tuning in.